Hi class, we're going to look at section 2.1, tables and trends. Our goal today is to create tables from formulas and to find the long-term behavior of a function from a table of values. So we're going to combine both tables and functions together to get a better picture of our function. Example 1. A falling object is pulled downward by gravity, but its fall is retarded by air resistance, which under appropriate condition is directly proportional to velocity. When a skydiver jumps from an airplane, her downward velocity v before she opens her parachute is given by this formula here, where t is the number of seconds that have elapsed since she jumped from the airplane. Part A. Express the velocity of a skydiver 5 seconds into the fall using functional notation and calculate its value. Make a table of values from 0 to 15 seconds using increments of 5s. So let's go to our calculator. The formula is already in the calculator, but we need to create the table of values. If you look up here in blue, you see table set and table. The table set is where you create your table of values, and table is where you view your table. So I'm going to second because it's in blue. So second window. I want to start at 0, my table, and it said increments of 5. So my delta here, I'm going to change that to 5. I want my table to go out by 5s. I want the calculator to do it for me, so auto. So now I want to view my table over here. So second table. Now I see my table here, increments of 5, 5, 10, 15, 20, and here are my values. So let's put these values on our table. So I'm entering all the values. We also have to express the velocity of the skydiver 5 seconds into the fall using functional notation. And there it goes right here. Now we're going to use this information here to help us do part B, the average rate of change. Describe how the velocity of the skydiver changes with time. Include in your description the average rate of increase in velocity during the first 5 seconds and the average rate of increase in velocity during the next 5 seconds. So we're going to look at the first 5 seconds. So 104 minus 0 divided by 5 gives us 20.998 feet per second. In the second 5 seconds, we're going to subtract again 147.5 minus 104 and divide that by 5 also to get 8.472 feet per second. Now we're going to compare these two. You see during the first 5 seconds, the velocity is higher than during the second 5 seconds. So remember, it increases rapidly, then the rate of increase slows down. So the rate of increase in velocity is much less during the second 5 seconds than the first 5 seconds. Now we want to calculate the terminal velocity. That is, find the maximum speed the skydiver can obtain. So let's go back to our calculator and see here. We're going to look over here for the speed. So I'm going to change my delta on my table to a large number, second table, where I can see it converts a little faster. So I'm going to change my delta to say 500. So when I look at my table of values, it changes to the maximum value quickly. So 176. Feet per second. How long does it take the skydiver to reach 99% of terminal velocity? Let's see. 99% of, in mathematics of means to multiply. Change this percent to a decimal, so 0.99 of the terminal velocity, which is 176. So we want to find out how long would it take for the skydiver to reach 174.24 feet per second. Let's go to our calculator and see. I'm going back to my table set, and I'm going to change that back to 5. I had 5 earlier, my delta. Now, let's look at our table one more time. We want to find when our velocity will be 174. So 174.24 is between 25 and 30. So I'm going to change my table to start at 25 and go up by, say, 0.5 this time, 0.5, and go up by 0.5 or 0.1, make it a little smaller, and see can I narrow in or zoom in on my answer. Second table. So 174.24 is between 25.3 and 25.4, round to the nearest whole number, so our answer is 25. We see that 174.24 is between these two numbers here. So I'm going to predict it would take 25 seconds for the skydiver to reach this velocity here. I must answer in complete sentence as a question. So it would take the skydiver 25 seconds to reach 99% of terminal velocity. I hope this helped you in your assignment for today. So if you need any help, please contact me, email me. Have a good day, and I'll talk to you soon. Bye.